Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to talk a little bit about using some simple scripting in order to make your life a little easier. In a previous video, we showed you how you could use netcat in order to send information easily across your network from your subject machine to your forensics workstation. We talked about some of the advantages of doing that. And we said that this is a situation that is ripe for scripting. So in this video, I wanted to show you how you can accomplish that. So right now, I want to start out by discussing the server side, or your forensics workstation side of this equation. So what I have here is a very simple script, and it starts out with our favorite shebang, bin bash. And what this script does is it sets up two listeners. There's a listener that listens on a certain port by default, 4444. And everything that comes in, it puts it out to a log file for a case. And there is another listener that by default is on port 5555, and it listens for file names. And as soon as it gets a file name, it opens up a listener on port 5556 and attempts to receive a file that's being transferred from the subject machine. So pretty simple stuff. Should also, if you're not familiar with shell scripting, this would be a nice introduction to that. And also it will show you how you can do a lot of stuff with netcat, because that's all I'm using in these scripts. So this script is called start case, and it accepts one parameter, a case number. Now, it doesn't matter what you want to call your case numbers. I like just using the date. It's very simple. Unless you're super busy, you're probably not having more than one case a day where you're investigating a Linux system. If you do, you could always append numbers to that, but do whatever you like. And so here I've defined a simple function called usage. And in order to define a function in shell scripting, you just give it a name, follow it by empty parentheses, and then in curly brackets, you put your code. So this is a typical usage function. It just says echo usage $0 is the name of the program you ran, and case number. That's all it does. And it tells you what it does, and it exits. So on the next line, I check and see if you actually pass something in. So $pound or $hash, depending on where you're from, is an environment variable that points to the number of passed in parameters. So if you passed in less than one parameter, then you get the usage displayed and it exits. Else, it says, I'm starting a case. And it's the case number that you gave me. Then I check and I say, does a directory exist for that case? So if not, -d, if not a directory by that name, then I make it. Now, one thing, if you've never done any shell scripting, you'll notice that shell scripts very particular about certain things, such as spacing. So notice I have if space square bracket space not space -d space $1 space bracket space semicolon then. And all of that's required. Another thing you'll notice about shell scripting is often if you start a section, such as I've done here with if, I close it with phi. if spelled backward. So far, nothing major going on here. Now I create the log listener, and I use netcat. We talked about the syntax in a previous video. So here I say netcat -k for keep it alive, -l, and the port I want to listen on, 4444. Everything that comes in, I will append to a file, and the name of that file is my case name, which is stored in $1 /log.txt. Now you'll notice that I have this command enclosed in backticks. That's just a way of saying please run this command. And then I have an ampersand which says please run this in the background. So this allows me to continue with my script. As soon as I've started that listener, I echo started log listener for the case on this date. And here's another little trick. If I put $ and then within parentheses a command, that command is executed and whatever it returns is put in this place. So this will put the current date and time, and I pipe that to my listener. I also start the file listener. Now I start the file listener by calling a script. So once again, in backticks, I call the script and I give it a parameter, the case number, and I background it. And this script will exit. So let's have a look at the start file listener script. This script starts out similarly with shebang, bin bash. It will also display a usage if you did not give it a case number. It will also complain and give that message if you passed in less than 1 parameter. And in this case, what I do is say file name is a variable I'm going to define, and I'm going to set it equal to the return value from this command, netcat -l 5555. So what this does is it listens on port 5555 for you to input some information on that socket. As soon as that happens and it gets a new line, it exits, sets that value equal to file name. So file name is a variable that holds the value of whatever was passed. So we'll see in a later video the client side or subject system side of this. So now that it has a file name, it opens a new socket, a new listener on 5556, and everything that it gets, it then pipes to $1, again the case number, that directory, / and then it will store this in the file name that was sent. Now I'm using this function called base name, and what base name does is that it will strip the path off of that. So for example, if I suspected that bin bash had been trojaned, this would create a file name called bash, not bin bash, in my directory. So I have an infinite loop here. I say while true, do this, and then call done. So the only thing that remains to be done on the client side is to clean up when you're all done. And I have a simple script for that called close case. Once again, shebang, and it echoes a little message. I'm shutting down the listeners at date and time. At a user request, it sends that to the log listener, and then it calls kill all on start case, kill all on start file listener, and kill all on netcat. So this will clean up everything that was started as part of these scripts. Well, that's all for this video. In the next video, we will look at the other side of this equation. As always, if you're enjoying these videos, make sure you tell a friend and help us to bring you even more of these videos. We'll see you next time.